and set the max works. But when we working on the industry, we really need to get a integrated solution, which is robust in the real world. That means that the method need to be very working on a lot of situations and be very robust. I think that's the big challenge we are facing in the industry. So in terms of this, we have to be very systematically build the solutions, integrate the state-of-the-art method, and build the system. Yeah. So in terms of this, and I think the academic can contribute on this one, is that developing very novel solutions. And meanwhile, we need to integrate and build a robust system. Yeah.
Let's see. So for our interactions with research, world universities, the main reason we do it is to kind of see the future, maybe the 10-year out, farther out. How's the world going to change around us, and actually try and learn by participating. Probably what works better for us is establishing kind of longer term relationships rather than transactional interactions. And so we try and end up with a shorter list of collaboration partners, where actually, know the down to knowing the professor, and like you take the time to share your interests, and they share their interests, whatever they might be, and you're trying to find good solid intersections that are durable over time, that then form the basis for working together. And from there, we usually try and find something small to work on together and kind of build the relationship from there. So I think it's a lot of that. It's the technology is very much a part of it, the learning, the talent pipeline. That's a very important element for us. But I think the part of getting it to work turns into, like, inevitably back to people and relationships.
Great, yeah, that's great to hear from you guys about your perspectives. So I think next I'd like to open up for questions from the audience. So if anyone in the room has any questions for any specific industry representative, or you have questions for everyone, feel free to just raise your hand and ask a question. Yeah.
All right, self-question. How has the panel, have you found that people on the sites have been reacting to robots and automation? Are they embracing it, or are they fearful?
So from our perspective, we have been working with a construction company in Japan, and their main concern was pedestrian object detection. Like, if you put an autonomous, like we're working on an autonomous bulldozer application, and their main concern is to have really robust object detection, because you don't want the autonomous vehicle to you don't want it to happen. And the thing that the main differentiation between passenger cars is that the environment could be highly unexpected in construction sites. So that will be like our main challenge, object detection, mainly pedestrians, and also trajectory planning to avoid collisions with stationary and non-stationary objects.
Sorry, I thought you were. Let's see. So it's, for us, I think it's been following the kind of standard 20% early adopter, 60% kind of looking to see, what's actually going to happen, what's going to happen when, and the 20% it's never going to happen kind of curve that you usually see, and kind of changes. I think inevitably it feels like we're ending up, there is a tension, there is a mixed reaction, but in general there's a lot more of a, well, let's look and see, because it tends to be that we're automating what are, in the end, the dull parts. You think of dull, dirty, dangerous. It seems like the dull is where the action is. It's just these areas that are so hard to get people to actually access to the folks that can actually do that work, and it's highly repetitive and not. So if you start posing it more as a tool to help people make them more productive, which is really what the goal is, then it's inevitably, I think it goes to, it's a pretty pragmatic industry. So it's like, I like what you're saying, but why don't you show me? And it's not so much show me like in a video, it's show me on my site with my crews, does this thing work? So it's fairly pragmatic, I think we've been finding.
Yeah, I would like to share some experience or feedback when we collaborating with construction companies. And the one thing that in the real world, there's a lot of problems, scenarios, and some scenarios are relatively easy, and some scenarios are really difficult in terms of research. So the people working on the construction, they don't know which task is relatively easy to solve or relatively difficult to solve by research. But I think that's very important for our researcher needed to understand that this problem is feasible to deployment, have some solution to deployment. And this kind of problem is too complex. Maybe it's 5 years, 10 years range to solve. I think it's very important that the research need to communicate, discuss with the end user and distinguish the problems. Which kind of problems is tackable in short time, and our technology, robotic technology, which can be applied it and solve it immediate in the short time. And which kind of problem is more research mode. I think that's very important. Otherwise, we spend a lot of efforts and still cannot get some solution delivered to the end user. Yeah. And another thing I want to emphasize in construction situation, that's a lot of the task planning, because it's not like the simple, as we said, it's long time horizon tasks. So how to planning the sequence of the task or the strategy which can solve a long time horizon, I think that's very challenging. It looks very simple to do A, B, C, D or something, but how to plan it sequentially, efficiently, consider all the logistics, I think that's a big challenge. And we saw a lot of research in the table indoor, like kitchen, such kind of manipulation, but they are not addressing such kind of the large scale and a long time horizon planning problem. I think that's a very important and a very challenging research problem. So for the community to focus on and address them.
Yeah, sure. I was thinking about, oh, I'm gonna give my comment first. Sorry. I was thinking about, if you look at social media and the kind of public perception of robotics, often you get this real scary pushback, like, oh, ChatGPT is going to steal my job, or this robot is going to steal my job. And you see it on YouTube when you advertise what you're working on, and sometimes you may even get it from your academic papers when there's some local press. But I can share our own experience of using automation on a job site where not a single job has been pushed out, because we're not replacing jobs, we're adding capacity. In all the places that are the most interested in robotics, they're already suffering from a labor shortage and a lack of people who want to do these jobs. And I think you nailed it. It's the dull, repetitive jobs that are it's the low-hanging fruit, but it's the work that benefits the most from this automation. And I think maybe people aren't appreciating is these dull jobs also have this kind of low-level hazard that takes a toll on the worker's body and forces them to retire early with a blown knee or blown shoulder. And these are also where the robotics came in. When Marco gave that presentation using the Moog excavator, and what did he say that is super smooth with automation? That you can have a guy in there that is not going to shake his body apart all day, right? That there are direct benefits to people, and it's cool for recruitment. I mean, we're suffering in all these places, but we're using technologies now on site that is going to bring people back because we're keeping them safe and we're giving them really interesting tasks to do. So to the fear, I can always give a story of robots are not taking anything. They're empowering a whole new generation to do this construction work and do these really cool jobs. Hopefully, question, I think.
Yeah, we don't have an extra mic, so if you have a question, you can just feel free to stand up. Yeah.
I'll repeat it.
The question is like more about all these companies that they have very multi industrial efforts, whether it's e-trans, there's agriculture, not only construction. So do you have any frameworks for transferability of research that you're doing? What do you do? So is there like how do you tackle like going to construction to other guidelines from agriculture to any other?
Sure, I'll repeat the question for the online people. The question was about with all these different industries all pursuing robotics, are there frameworks that allow us to move these technologies, techniques between them? Jump on. Yeah.
So like as a research scientist, there is a lot of like the analogy between construction vehicles and manipulating robotics is tremendous. So you can look as a roboticist, there are two like main challenges. First is the drivability, and then to how to move your payload. So these are the two main questions. So in our example, we had a dozer and it had both of the problems. So it had a manipulator and it had the drivability. And the main differentiation between the off-road setting and the on-road setting is that you can stop. So it will be suboptimal. Your customer might not be satisfied with the results because it takes more time if you stop, but you can stop. So, and the fact that you can stop, I mean, stop the process, right? To stop the application process, lets you deploy faster. So we can deploy, test, retrain, and so on. So that's like a good example of how to interact with other applications within Bosch, for example.
Yeah, I can share our experiences too, that many of the techniques, say in automotives, can be applied in construction. It's for us, the dynamics is just different, right? We're usually going a little slower, but gives us more opportunities to make more complex decisions. Definitely, we recruit from everyone who has robotics experience. We're not discriminating if it's specific to construction or other industries.
Yeah, I would say that robotics, we have developed a lot of components like a perception, planning, collision avoidance, navigation. All these are very general technology which can be applied to the agricultural robotics, construction robotics. So I think that's very important. We don't want to, for every application, we develop the wheel, revamp the wheel again and again. We want to make use all the literatures, all the components which we have invented already to apply it to construction robotics. So for example, like the perception or segmentation or object detection, all this has been being used for the self-driving high speed or public road situations. But all this method can be applied to the field robotics as well, like construction scenarios. We also need to detect the truck, detect persons. So all these components can be applied and then further be tailored for this particular application here. I think in terms of industry, a very important issue is that the scale. We need to be able to scale the system from one machine to multiple machines. So you raise a very important thing that reuse a lot of components and building the common component which can be reused for a lot of platform. I think that's very important. A successful factor for the industry. Yeah.
Building on that, and we see a lot of reuse across the different domains, but it depends. And so you see in some of the presentations this morning, it's, this is a connected robotic ecosystem. And so you're thinking in terms of technology stack. And so some parts, there's a lot of high commonality across the different domains, but there's other parts of that stack that are very much domain specific. And so it's understanding wherever you're playing within that, where are you? And then what are those differences? And there's a technical version of that. And then from a kind of business axis, there's also the same axis. The way the market works could be totally different, who your partners are going to be, and what their interests are, what problems they're trying to solve. So it's sort of like this, a startup dilemma, sort of a story as you're targeting these different areas. We do look at it from a technology point of view, and hey, right, there's a lot of these high commonality areas, but then we inevitably, you don't automate a machine, you automate a task. And so then understanding the task and who the problem owner is and what's valuable to them, so you're not solving the wrong problem, end up being a lot of the challenge. So I guess I'd mainly say, probably think of it in terms of like, yeah, this, I divide the problem into kind of layers, and then what area am I drilling into on the research side, or whatever I'm going after, and thinking about from that perspective. Yeah, I saw your hand come up first, gentlemen, shout it out.
Thanks for the presentation. And my question is about how do you bring an idea into mind? So let's say that you have an idea either from industry or from academia that's on the table, and then you collaborate with academia. Hopefully you'll get a proof of concept. And then how do you build a robust system, or let's say a scalable system from that proof of concept to be able to deploy and construct something?
We're still at the early stages on the deployment side. So I think inevitably it starts with, well, what is a problem that's out there? And so who is the problem owner? So rather than starting, you don't want to start too much with here's the solution, and now I want to find the person with the problem. And so, but inevitably you're listening as you're looking for those as things you have some basis to start off of. And so finding something small to get to, you can get to fairly quickly, a lean innovation sort of model where you're getting a minimum sort of solution in front of people, because this is so new for all of us. Just even articulating what it is you're trying to do, what problem you're trying to solve, and how you might do it is really hard for everybody. And so there's a little bit of, I'll know it when I see it. And so you're trying to then listen and find where those opportunities are. Say, I think I could actually put something together there that, and then after listening to enough, you start finding commonalities across problem sets. But it's like, it's an iterative approach in general, and it's get something in front of folks. And then, if that's valuable, make it a little bit better, find out where the shortcomings are, might require research that actually comes out of it, that where your existing book of solutions isn't good enough. That drives then the kind of iterative research sort of roadmaps, is at least the approach that comes to mind when you ask.
Yeah, I would like to see that there's a big challenge to identify the problem, because when we talk to the end user, basically we are speak two different languages. The end user, they are speaking the language in their domain, like the constructions, they have their own languages, their own knowledge, terminology. Where from research community, where the language we are speaking are very different. So in terms of this, I think we need to be very proactively to understanding from their point, what's the challenges they are facing, and identify the good problems. Yeah, otherwise will be a lot of time will be wasted to when talk to them and interact with them. I think the identify the problem effectively is the most important things in terms of the entire loop. Once you have the essential problem identified, the next step, of course, is to develop good solutions and keep refining, iteratively refining the solutions, and that becomes more natural. But how to identify the problems really to solve their pain point, I think that's a big challenge. Yeah.
Thanks. Yeah, I can continue that theme. I guess this is what we're all dealing with, right? That maybe as engineers, we have this tendency of hearing the problem and thinking of a solution and just go. And I'm going to do that. And I think probably for all of us, we always have to stop and stop our teams to say, okay, what is the actual problem, right? We got to dig in. Why? We saw the presentation from ICRA this morning that 30 to 50% of work on a construction site is actually rework. Why? What was the source of that error? Miscommunication. Why? Why aren't people talking? Well, they have different plans. Why does that happen? Well, they're issued by different subcontractors and they're not talking. Why can't we use a common system? Well, we haven't established a standard. Why can't we lay out to a common standard? Well, people use different contractors, they use different surveyors. Why can't we get that into a single layout system? And we get into positioning and surveying and forcing our teams to kind of go through those classic ideation methods of the 5 whys, or who are my stakeholders, or what are my actual tasks? That's the core bit that allows you to dig down to what is the central problem, and then dig back up with those solutions and the alternatives. And so keeping your team's minds open to those alternatives and figuring out what is actually valuable to the stakeholders, the people that are asking those questions, is a big part of that process.
So a big addition to what was said before, you should always start with the why. And the why is a big thing. So for example, in construction site, you have experienced driver, they retire. You have young young workers, they don't want to do this work. At least they don't want to do it alone. They would have to have a robot to assist them. And actually in manufacturing, you see that all the time where you have cobots. For example, in Bosch plants, you have a drilling task. And if you would have an employee to hold the driller at like 30 kilograms weight, to hold it for 30 years, that wouldn't last. That's not sustainable. So you have to have